Hello everyone. In this video we're gonna start talking about the rotary system. So we discussed so far the power system, hoisting system, circulating system, and now we're gonna talk about the rotary system. So the rotary system include different equipments that the goal of the rotary system is to provide rotation, as the name implies, and provide the rotation for the drilling bit, and once the drilling bit rotates, the rack is cut and then you can drill forward, right? So there are many components for this system, and these components include the swivel, which is here right at the top. We will discuss each of these components separately, but there is a hose here connected to the swivel, which we will see it later. This is Kelly. It's basically a pipe, but different shape from the drill pipes. And the Kelly is connected to the rotary table. So let's say if you have a rotary table here, if you're looking from the top, Kelly could be a square or hexagonal shape. So there is a part here that the Kelly is going to be connected to here, right? Let's say if you have a square shaped Kelly and the rotary table rotates, rotate the Kelly will rotate. Once the Kelly rotates, it also rotates the drill string system and also the drill bit. So that's how it works. There's a rotary table, right? Kelly bushing, rotary drive, which provides the power, and drill pipe, drill collars, drill bits, which we will discuss them separately. So the swivel, as I discussed, all those loads, the Kelly, the drill string, everything is connected to this swivel, and it supports the weight of all these components. The bottom part is connected to the Kelly, so Kelly is connected to the bottom part of this swivel, and then here there is a part which is called gooseneck, and the gooseneck is connected to the mud hose, right, or rotary hose they call it. So the mud is gonna be injected from here through the gooseneck into the swivel, into the Kelly, into the drill string system. So the swivel is rated based on their weight, how much weight they can load, and what is their load capacity, because they need to hold the whole drilling system. The next part is Kelly. After the swivel we have Kelly. It's usually 40 to 54 feet length, and the cross section of the Kelly is either a square or hexagonal, and it grips into the it is attached to the Kelly bushing, and Kelly bushing fits into the rotary table. So once the rotary table rotates, it rotates the Kellys, and then the Kelly rotates the drill string system, as I discussed. So the main functions you can see here. It transmits the rotation, weight on beat, support the weight of the drill string, of course, and then connects the swivel to the upper part of the drill pipe, right? That's the midsection, and it also transfers the drilling fluid from the swivel into the drill string. So these are the main functions of the Kelly. The next part is Kelly Saver sub, and Kelly Saver sub is kind of a small attachment, and it's the first joint between the Kelly and the first joint of the drill pipe. So it's a sub basically. The length is short, and it's screwed to the bottom of the lower Kelly, and it's just a mid connection. So the reason that we use the Kelly Saver sub is because, for example, is if the Kelly turrets, it prevents the wear on the Kelly turrets, right? Because the Kelly is connected. If we didn't have any saver sub, then the Kelly would have been connected directly into the drill pipe, and since we open these connections and close these connections, tight these connections a lot, then it may wear the threads on the Kelly. So we don't want to change the whole Kelly system, which is 40-50 feet pipe. Instead, we use these subs, and we just change that sub, which is going to be much cheaper and simpler. The rotary table provides rotation, as the name implies. You can see that's where the Kelly will basically go in, right? And that's basically it. Another part of the rotary system is the drill pipe, which is one of the major portion of the drill string system. There are 3 different ranges of the size of these drill pipes. Range 1 18 to 22 feet, range 2 27 to 30 feet, range 3 38 to 45 feet. Most of the drill pipes are range 2 27 to 30 feet, and the drill pipes are rated based on their outer diameter, their weight, how much weight they have, the steel grade, and the range length. So all these parameters are really important. For example, the weight per feet is really important because the weight of the drill pipe provides a weight on beat. So what causes the drilling to happen is 2 things. One is the rotation of, so let's say here is the level that we are drilling at, the surface at the bottom of the well bore, and here is your drill bit, right? 2 factors play a really important part. One is the rotation of this drill bit, rotation, which provides RPM, rotation to the drill bit, and another factor is weight on beat. And this is another design parameter for drilling: how much weight on beat you need to have, what rotation speed you need in order to effectively drill a portion of the underground formations. So this drill pipe weight, it plays an important role because that provides the weight on beat, right? So whatever length that is going to be multiplied by weight of the drill pipe, and that would be the total weight that is being inserted into the drill bit. Of course, there are other components as well, but this is one of the main important parts. Steel grade, the quality of these steels are really important. How much tension or compression can these drill pipes stand? For example, if your pipe is stuck underground into a formation due to different reasons, and you want to pull this drill pipe out of the well bore, then you need to have a good steel grade. The higher the steel grade, the better the steel. You can pull it with more force and get rid of stuck pipe situation. The lower section of the drill pipe is another pipe which is called drill collar. So this is not how it exactly look like. So this is the drill pipe. There is another pipe which is in which the length, the diameter is higher than the drill pipe, and this is called drill collar. So drill collar is heavier. The inner diameter is usually less than the drill pipe. So it's a pipe like this. This part is all steel, so it's heavy, right? The length is not as high as the drill pipe. Is the bottom section, 600 feet, 500 feet is the drill collar. And the main duty of the drill collar is again to provide a heavy weight on the bit, to provide the weight on bit, this factor, right? So this is another part, and this table provides the different types of drill pipes, not the drill collars but the drill pipes. You can see the outer diameter is one of the important parameters, right? That we have weight per feet, sorry. So for example, one specific size, let's say 4.5 inch, could have 3 different weight per feet, right? Depending on the inner diameter, right? So you can see that the inner diameters are different, right? The smaller the inner diameter with the same outer diameter, you have a heavier pipe because you have more steel there, right? So the internal diameter are different, but usually when we report these drill pipe sizes, we talk about the outer diameter and weight per feet, and then you go and find all other information about this pipe from these type of tables. So what else? We have the collapse pressure. We'll talk about the collapse and tension and yield pressure, all these parameters later on. But you see that they have different grades here, right? The tensile strengths of grade D, grade E, grade G, and grade S here in this table, right? So these are different grades of the drill pipe that we were talking about in previous slide. So next video we're gonna do some calculations regarding the drill pipe, which is called displacement and capacity of these drill pipes, and I'll see you in a bit.